This is the video for question 1. In question 1, we know that we have a probability of x equal to k is b multiply k times of k minus 1's power of p. And so in the first question, we need to find b so that the probability of x equal to k represents a probability mass function. And so k have infinite numbers, and if we want to get the probability mass function, we know that when we sum of all the probable possibility of p, probability of x, we can reach the number should be equal 1, since this is the probability is equal 1 in the total. The total probability is equal to 1. So then we have to deal with the equation of the case k minus 1's power of p, and we have some equation which can expand this probability, expand this equation. So when we expand the k's power of p, we get which is the sum of the different k's value. The limitation number is 1 divide 1 minus p, and so we have we have number can use in the calculation, a formula for calculating, and then we can we have to differentiating both sides with respect to p. And for the further differentiate, we can get k. We can get the sum of k multiply k minus 1's power of p, and which is equal to 1 minus 1 divide with 1 minus p square, and this we can use to calculate the second and the first question, and then we can also differentiate both sides with respect p, and we can get the two times of the differentiating numbers. And then to solve the total question, we also have still differentiate both sides with respect to b, and we can get the cubic of k, and so we can get we can solve this problem by expanding the equation, differentiating both sides, and we can get the formula we want, and put in this formula into calculation of expectation and probabilities calculation. We can get the final value we want. This is how to solve this question. All of the process and the formula and the equation on my papers, on my homework papers. So it's a little bit to just talk about those processing and those translation or something. But if you want, you can find the formula, find the equation on my paper. So thanks.